we really need to stay up to snuff here on this stuff. So we've got the Cartesian plane there, and we've got a point plotted down here. And it says the complex number W is graphed below. Write W in rectangular form. Now remember, if it's a complex number, its rectangular form is this. Okay? So, can you get an X and a Y from what they've drawn for you? Yeah. So what is your point in rectangular form? -6 minus 3i. Don't make it hard. That's easy. Now, write it in polar form. Now, if you're going to write it in polar form, you have to know an R and a theta. Remember, rectangular is XY. Polar is R theta. Okay? So, if we think about this for a minute, we know that X is R cosine theta, and Y is R sine theta. So this is going to be my polar form, but I got to figure out what the R and the theta are. So remember, it's easy for me, it's easiest. You may have another strategy. I like to just make my little triangle, and I know that this is -6 and this is -3, right? Yep. Can I find my R? Yep. What's my R? Be the square root of 45 or 3 root 5. So 3 root 5 cosine something, I haven't figured out what that is yet, plus I, 3 root 5 sine something. This is your polar form. Our mantra, X equals R cosine, Y equals R sine. Okay, now I need to find my angle. Now, the angle will, in the final, be this right here. It must be in standard position. But we won't find that right off the bat. We'll find this one right here, right? How will we do that? Well, we need a calculator, because is root 45 one of our special things? So if we had root 3s and 2s and 1s and stuff, maybe we could do it without a calculator, but we can't do this without a calculator. So what do I type in? Second tangent 1/2. 3/6. Second tangent, tangent's y over x. And I got 0.464. But that is not my theta. What's my actual theta? Pi plus that, so just plus pi. Perfect. 3.605. And there is your number in polar. Okay? All right. Number 2. A complex number is represented in polar coordinates as 5 2 pi over 3. So 5 2 pi over 3 is your point, and it says find the real and the imaginary component. In other words, find what? X and Y, right? Real, imaginary, X and Y. Well, how do we find X? What is X equal? R cosine theta. No calculator necessary for this one. We can do this one exactly. Exact means no calculator. We don't need one. That's one of our angles. And y is going to be 5 sine 2 pi over 3. Okay, so cosine 2 pi over 3. 2 pi over 3. Cosine is 1/2 negative. So this is 5 times negative 1/2. And this one will be 5 times positive root 3 over 2. So, negative 5/2 plus 5 root 3 over 2i is the rectangular form of that number. What is this beeping? If that's your phone making those dings, go turn it off. Okay? Maybe it's done. All right. Now, what's the real part? Your job was to find the real component. So the real component is negative 5/2, and the imaginary component is 5 root 3 over 2i. Write the complex number in standard form. Again, you guys, this is not hard. Standard form is x plus yi, right? So we need x. And how do we find x? X equals r cosine theta. So x equals 8 cosine pi over 2. And y equals 8 sine pi over 2. That 8 is outside of parentheses. So if you wanted to write it the way Mr. Passwater does, it would look like this. It's the same number. There's x, there's y, right? So what's the cosine of pi over 2? 0. And the sine of pi over 2? 1. So your number is 0 plus 8i, or just 8i is fine. 0 plus 8i. And then finally, 4 minus 4i, we're going to write this in polar form, which means we're going to write it like this. We're going to write it as r cosine plus I times r sine. Okay? So, what do I know here? What's that?
I get a feeling that R is going to be 4.
No. But it's good to have, be thinking about it. But what are these? These guys are X and Y. So if I plot that point, right 4, down 4, here's R. So what's R going to be? 4 root 2. Yeah, you were close. So R is 4 root 2. Now I need to find theta. Be careful. Can you tell me how big this angle is? I hope these match.
45.
So this is a 45-degree angle, or in radians, pi over 4. But pi over 4 is not theta. Theta must be in standard position. So what is theta? 7 pi over 4. And there you go. Okay? Now I'm going to give you a couple of things. One thing I'm going to give you, I'm just going to pass these around. Just take one. I don't think you're going to need it, but I'm going to give you some polar graph paper because we're going to be graphing. But we have it in the notes already, but just in case you need some extra. One note on the AP exam. You will not have to create a freehand polar curve. However, you will be asked to analyze polar curves, so we need to understand how they work. but you're not going to be physically plotting points and creating one. But grab a piece of paper and pass it around. What you're going to work on right now, what we're going to work on together, I have a worksheet, and this is actually for 3.13 and 3.14, so hang on to this guy. All right, guys, here we go. Here we go. We are not going to, there's a lot of problems here. We're not going to do them all, but we are going to do some of them together right now. So would you turn to number 3? We're going to start with number 3. It says plot and label these points. Okay, so we need to be able to plot and label these points. All right, so yours is going to look better than mine, but here we go. 2 comma negative pi over 6. Please pay attention, work with me. There's a method to my madness here. 2 negative pi over 6. Well, where's negative pi over 6? Down here. And 2, I didn't put all the little subdivisions in there, so I'm just going to put it right there. That's point A. Everybody okay with that? Get it in the right spot? Negative 3, negative pi over 2. Now, this is the case all the time. You develop your own way of thinking about it. How does it make sense to you? Personally, I don't process negative r's very well, so I'm going to make it positive, remembering that when I make r positive, my angle changes by 180 degrees or pi radians. So this will become positive pi over 2, and the point then is going to get plotted right there. Now, as long as you're getting it plotted there, I really don't care how you think about it. You don't have to think about it the way I do, but you got to get it plotted in that location. Negative 2, 3 pi over 4. Are you getting it in quadrant 4?
Yes.
On the second circle at the pi over 4 angle. And negative 2 pi over 3. That one's going in quadrant 1. On the, for me, the pi over 3 angle. Remember when I change the sign on R, my angle changes by 180 degrees? Or by pi? So what happens if I add pi to this? All right, anybody have a question about those? Again, he's got a million examples on here. We're not going to do them all. Everybody okay with getting those plotted? All right, let's look at number 4. We have a point in polar coordinates 4 comma 5 pi over 6. We want to write this in different ways. Okay, so can you think of a different way to write this? What would be, like these 2 points are the same. It's different ways of writing the same point. What would be another way of writing this point? Negative 4, 11 pi over 6? What do you think, kids? Yep, change the sign on R, add or subtract pi. Perfect. Another one, Xander?
Negative 4, negative 5 over 6.
Okay, what do you think about that? Is that one okay? Let's come up with one more. I know it only says 2, but let's get one more. Josie?
4, negative 7 pi over 6.
Oh, 4. Negative 7 pi over 7. Now, notice what Josie did. She did not change the sign on R. So she wants to name the same angle, so she has to add or subtract 2 pi? Find a coterminal angle, in other words. She did not change the sign on R. Anybody have a question about that one? You feel okay about that? All right, next, let's look at number 10. We've got 2 5 pi over 3. And we want to know the rectangular coordinates. Okay, so remember, rectangular means we want x and y. This is our and theta. Xander?
No, I'm sorry.
Come on now, you can do this.
No, it's, yeah, I was sorry. I was working on number 5.
Oh,
But, yeah, I'll get there, number 6.
okay, yeah. So number 10, we're on number 10.
Let's go, negative 2, negative pi over 2.
Okay, I don't know what you're doing. Let's look at the
My bad,
directions.
yeah, I was on
Let's
6.
look at the directions for problem number 10.
Okay, yeah.
It says, I want to find x and y. Okay, so we're shifting gears, it's a different problem. How do I find x and y?
2 cos.
Exactly. X is going to be 2 cosine 5 pi over 3, and y is going to be 2 sine 5 pi over 3. You should go to bed at night saying, x equals r cosine, y equals r sine, over and over and over again. Okay, what's the cosine of 5 pi over 3? No calculator necessary. Cosine is 1/2, and sine is negative root 3 over 2. So when I multiply, it looks like x is 1 and y is negative root 3. So hopefully that's an option. Negative 1, negative root 3. Yeah, C is the option. Okay. Another one, let's go to 15. 15. Okay, so the location of point A in rectangular coordinates is negative 1/2 root 3 over 2. Now, what does rectangular mean? What are these? This is x and y, okay? Now, what do we want to know? What are the polar coordinates? Which means, what are we trying to find? R and theta, okay? Raina?
Those points are 2 pi over 3.
So, Raina says, this is over here, right? And this is the point, negative 1/2 root 3 over 2. Negative 1/2 root 3 over 2. She says, I recognize that. She said, that's 2 pi over 3. Would you agree?
Yeah.
Okay. And not only that, okay, so the angle, theta, is 2 pi over 3. But not only that, but isn't that point on the unit circle? Isn't that what, that is actually one of our points? Which means the radius is 1. Now, you could do the Pythagorean theorem to figure that out, but since it's one of our points on the circle, I won't. So what are the coordinates of my point? 1, comma, 2 pi over 3. Okay. I want to do one more. Let's do 18. I'm trying to do a little of everything here. 18. A complex number is represented by a point in a complex plane. The complex number has these rectangular coordinates. Which of the following is one way to express the complex number using its polar coordinates? So in other words, the actual number is this, x plus yi. And we're going to change that into its polar form, which is r cosine plus I r sine. Isn't this kind of what we just did?
Yeah.
Except now we're writing our answer not as a point, but as a number with an I. I think that's another one of our points, isn't it?
Yeah.
Isn't that one on the circle? Down here at negative root 3 over 2, negative 1/2. How big is that angle? I heard a couple of things. I heard 4 pi over 3 and I heard 7 pi over 6. Both of those are in the right quadrant. Which one is it? I think that's a pi over 6 angle, isn't it? So 7 pi over 6 is my angle. And again, I'm on the unit circle. So 1 cosine 7 pi over 6 plus I times cosine 7. Now, because that's a 1, we technically could leave it out. So he left it out. So it looks like the answer is B. Everybody okay with that? All good? Now, there's plenty more problems here to practice. Keep in mind, we're not doing worksheet 3.14 as part of this packet. So number 20 is the last one on this page, or on this set. But tomorrow, we're gonna have a quiz. And I just went through and did one of everything from the worksheet for you. And that's what I'm gonna do for the quiz. I'm gonna pick another, I'm gonna make up a problem similar to the ones we just practiced, and you're gonna do it tomorrow. If you feel like you need more practice, then you got it right here, right? You got more problems to practice. Okay, everybody clear on that? Okay, perfect. Okay. All right, so now let's get back to our notes. And we're going to do this a little bit different this time. We're going to do the calculatic part first. So go to where it says polar phenomenon, part 1. And it has a penguin up there. We're going to come back and do all the notes, don't panic, but I like the way they kind of go through this. Okay, now we do not have or use the technology they're talking about, so I don't want you to worry about that. We're going to answer the questions, but we're not going to use their technology. We're going to use our calculator. Okay, so first problem, we're not going to the folder and all that stuff. What is the independent variable and what is the dependent variable in this equation? So the equation, and I'll just use the one from number 2, it's of the form r equals 5 cosine theta. Anybody want, these are ordered pairs, right? What do polar ordered pairs look like? R comma theta. Now this is another difference between polar and rectangular. In the rectangular world, your ordered pairs are x comma 1, and your equations look like y equals, 3x plus 2. And when you set up your t-chart, you have your x's and your y's. And back when you were first learning how to graph, your teacher probably told you to do what? Just pick some x's, pick them, and then put them in and figure out the y's. So in other words, the y's depended on the x's. So x was your independent variable, this was your independent variable, and this was your dependent variable. Another way to think about it is, when you got a little older, you wrote this equation like this. Didn't the value of the function depend on x? So x is independent, okay? Now, in polar coordinates, it's the other way around, because the value of r depends on the value of theta, but when you write your ordered pairs, it's r comma theta, but this is your independent variable, and this is your dependent variable. So even though polar graphs aren't functions in the sense of vertical line test and all that, sometimes you'll see these written like this, to remind you that theta is your dependent variable. Okay, we have to be careful with that notation. It's okay. I mean, it makes sense to use it, but you'll see these are not functions in terms of vertical line tests, what you think of as a function. Okay, all right, so let's go ahead and graph this equation. Number 2, the first one there. So we're going to graph 5 cosine theta. So here's how I want you to do this. Now, if you've already done it before, it's perfect. If you haven't, please listen and just do what I say. First thing I need you to do is load. We're already in radians because that's how we operate in this class. But now I need you to click down to, right now, function, FUNC is probably highlighted. You need POL to be highlighted. We're going into polar mode. So you need to click over to polar mode. Okay, everybody good? Now we're going to go to window. And for the time being, we're all going to set it up the same so that we're all looking at exactly the same picture. So for theta min, I want you to put in 0. And for theta max, I want you to put in 2 pi. Now, looking at the equation, can anybody tell me why that makes sense? For theta min to be 0 and theta max to be 2 pi. 2 pi is the period of the cosine. What happens if I go past 2 pi? I just repeat myself, right? So that would be dumb, the least time. Not going to do it. Now, theta step. We're going to talk about what that does, but for now, 0.1. 0.1. Now, if your default is 0.13 or something, that's fine. But it should be 0.1 something. Okay? We'll talk about what that does in a minute. X min, X max. Now, kids, we are graphing in polar coordinates, but what shape is your screen? A rectangle. So we have no choice. We have to tell it how wide, how high do we want our face. So we're going to give it an X and a Y. And I would say for this problem, negative, let's go negative 7 to 7. And that's Y and X. So min is negative 7, max is positive 7. For your X and Y scale, I would just leave it at 1. All right, everybody got it set up right? You go down, arrow down. All right, now go to Y equals, and we're going to type in our equation. But now magically, it doesn't say y equals anymore, it says r equals, because we're in polar mode, and type 5 cosine theta. Theta is your variable, so it's right there where your x is normally, right? So you just type 5 cosine theta. And hit graph. Now, here's the scoop. This is actually supposed to be a circle. This is the polar equation for a circle. But because your screen is rectangular, it stretches things more horizontally than vertically. So go to zoom and hit zoom square. For me, it's option 5. I don't know what it is for you. Hit zoom square. That will square your screen, make it a square now instead of a rectangle. And do you see a circle now? Yep. Okay, so you might just somewhere there, just kind of jot down, freehand, jot down what that circle looks like. Because now I want you to graph the next one. So clear that one out and type -2 cosine theta. Now, first of all, it's a smaller circle, but does that make sense to you that it would be smaller? Yeah. Second of all, it's on the other side of the y-axis. Does that make sense to you? Because the 2 is negative. And remember what negative r's do? They flip you to the other side, right? So that makes sense. Perfect. Okay, now let's go down to number 4. And let's do it. Let's not change a thing. Let's just type in 4 sine theta. You get a circle? Yeah. What's different about this one? It's on top, right? It is circled, its diameter, let me say it that way. Its diameter is the y-axis. Wait a minute, sine y, cosine x. See how things kind of fit together? Okay, and then the last one, -3 sine. Before we do it, what's going to happen? It's going to be down below. Sure enough, that's where it is. All right, everybody good? All right, turn the page, go to number 7. All right, let's not change a thing. Let's put in 5 cosine 3 theta. Okay, we're doing the first one, and again, it would really be helpful if you were making a little, writing down what your picture shows on your notes there. All right, hit graph. Whoa, whoa, whoa! This is a different picture, isn't it? This is what we fondly call a rose. This is a rose. Now let's talk about what we observe about this equation. It's r equals 5 cosine. Is this cosine? Yep, 3 beta. Okay? All right, what do we notice about it? There's 3 leaves, or 3 petals, right? Okay. 3 leaves and petals. Now, it's hard to tell on the diagonal ones, but on the petal that's on the x-axis, if your scale is set at 1, you can count hash marks. How long is that? 5? So these petals There's 3 of them, and they're 5 long. So let's look at the equation. Do you think there's a coincidence here? No. No. Pay attention to that, because you're going to be asked on some multiple choice questions. They're going to draw a picture, and you're going to have to decide which equation could fit that picture without a calculator. Okay? So keep in mind this observation. All right, let's go to the next one. -4 cosine 5 theta. Okay, what do you observe about that one? How many leaves does it have? So -4 cosine 5 theta has 5 leaves. And again, if you look at the one on the x-axis, negative x-axis, it's over 4. So they are 4 long. Next, 5 cosine 2 theta. And 3 cosine 4 theta. Huh. Well, how many leaves are there? 4. And how long are they? 5. Okay, so my original theory is kind of blown here a little bit. Let's do the last one. 3, is that positive 3? Cosine 4 theta. How many leaves? 8. And they're 3 long. Now in a minute we're going to do the sine version of that, but the rules are nothing's going to change. I mean, the orientation of the picture will change, but none of these fundamentals. So I have an equation. The next one I'm going to do is r equals 5 sine 3 theta. Without doing it, do you have a guess as to how many leaves there will be, and how long they'll be, Joe Funk?
3 leaves, 5 long.
Good, Joe. Now, what about the last one in that list, which is 3 sine 4 theta? Well, I'm going to let you type these in a second. But Joe, what's your thought about this one?
3 long, and I guess 4 leaves, but I feel like that's wrong.
There's 8. So look what happened over here. When this number right here was a 3, we had 3 leaves. When it was a 5, we had 5 leaves. But when it was a 2, we had 4 leaves. And when it was a 4, we had 8 leaves. So what appears to be happening here? If it's odd, if this coefficient on theta is odd, then that's how many leaves you'll have. So if we had 6 cosine 7 theta, there would be 7 leaves. And they would be 6 long. This is like the amplitude. Okay? Now, When that number is even, it looks like there are twice as many. So if we had 6 cosine 8 theta, there would be 16 leaves, and they would be 6 long. So the rows is anything of the form R equals A sine or cosine B theta. A tells you how long they are. B tells you how many you've got. If B is odd, that's how many you got. If B is even, you have twice that many. Okay? Now, when you did 5 cosine 3 theta, when you graphed this one, that was the first rows we graphed. Did you draw a picture of it for your reference? Okay, would you go ahead and do 5 sine 3 theta? And tell me what you notice in comparison to your cosine. Are you graphing it? You're just sitting there like a dud.
Doesn't work like that.
My graph doesn't work. All right, what did you notice? Did it come out the way Joe Funk thought it would? Did you get 3 leaves and 5 long? What was different about it though? It oriented differently? Guys, go back to the very beginning of all this. When you graphed a sine and a cosine, aren't they exactly the same curve, just shifted? So in a circular system, they're exactly the same curve, but rotated. Yep. Last thing on that page. For each of the graphs, so for any of these graphs, how can we figure out the angle between the petals? So guys, easy. What?
Wild guess, 180 divided by these.
Okay, it wouldn't be 180, 360, because aren't we graphing all the way around the circle? So think about it, guys. If you have this guy that has 3 leaves, then won't the angle between them be 120 degrees or 2 pi over 3 radians? Doesn't that make sense? If there's 4 of them, it would be 2 pi over 4. They're evenly spaced. Just like when you graph these, all of these hash marks are evenly spaced. All of your petals are going to be evenly spaced. Okay. All right. Now, before we do that, I want to go to the next page, polar phenomenon part 2. And we're going to do the same thing. We're going to graph these guys, and we're going to see if we can make some observations about them. So, I know you're dying to type this in. Number 2 says 2 plus 3 cosine theta. First of all, this equation looks different than a rose, right? Let's go all the way back. What did a circle equation look like? 5 cosine theta or 9 sine theta? That's a circle. When you take that equation, but you put a coefficient on here, that turns it into a rose. Okay? Now what happens when we stick a plus sign in there? I don't know. Let's see. might help, go to window. I want you to really look at this. Go to window and change your X's and Y's got changed by the zoom square. So go ahead and make your X's and Y's -6 and 6. So -6 for the X-min, 6 for the X-max, and the same thing for the Y's. And hopefully this opens up that picture a little bit for you. What do you see? What does that look like? You see that picture and you don't think of anything? Have you ever eaten a lima bean? Does it look like a lima bean? Some kids call it a Pac-Man. Well, I don't care what you call it. It's called a limaçon. In Mathland, this is called a limaçon. Now, these two numbers, the relationship of these two numbers is important as to what happens in the picture. Okay? Now, what do you think would happen if I turn that cosine into a sine? Take a wild guess. What's going to happen? Instead of beaning sideways, it's going to be beaning up and down. Graph it just to make sure. 2 + 3 sine theta. Is it the same shape? Is it exactly what we thought would happen? Now we're on the y-axis instead of the x-axis. Okay. Let's go back to number 2 on the paper here. 3 + 3 cosine. Now you have drawn this one. Guys, please draw that picture before you erase it. And then do this one. And tell me what you notice. I changed one number in the equation. What happened? How are they different? They're different. How are they different? Well, not these two. These are both cosines. So they're actually situated the same way, but this one has something that this one does not. This one has a little interior loop in it. This one doesn't. This one is actually called a cardioid because it's a heart shape. Alright, so draw a picture of that. Because now we're going to do 4 + 3 cosine theta. Kids, these are the things you have to observe and make note of. So that you can handle these multiple choice questions they're going to throw at you. Alright, what changes here? What does this one look like? What's the difference between these two? Where's the cardioid that we did here, the second one we did? Where's his little indentation at? At the origin? Where's this guy's little indentation at? Over at -1? If we have another x coordinate. Right? Alright, last one. 2 - 3 cosine. And we gotta make some general observations. 2 - 3 cosine. which was just like the first one, except I put a minus in there. And what did that do? What did putting a minus in there do? Exactly what you would think a negative would do, right? Flipped you, reflected you. So these two look exactly the same, but they're dented different directions. Okay? All right, so now we're gonna do number 3. The equations are of the form A plus B cosine. You have to make some general conclusions about what happens if A is less than B, what happens if A is equal to B, and what happens if A is greater than B. Okay, so let's look at this one. These guys right here, these are examples of A being less than B. So what was particular to those two equations? What did they have? They had an interior loop. And furthermore, did you pay attention? How big was the interior loop? 1. What is the difference of these two numbers? 1. So if we made this a 4, would it still have an interior loop? Yes, but now the loop would be bigger because the difference in the numbers is bigger. So this guy's going to have an interior loop. Okay? Now, what happened when they matched, when the two numbers matched? No more loop. Now we had our little heart indentation thing at the origin. So this has an indentation at the origin. And then what happened when A was bigger than B? We still had an indentation, but it was not at the origin? Didn't we? Yeah. Alright, I think that's my phone buzzing there. Alright, so let's see. Alright, so tomorrow, well, I'm going to stop there because we're almost out of time. So tomorrow, we have our quiz. And what can we do to prepare for the quiz? Some of you need to improve your grade, you know that. How can you do that? Do extra practice on the worksheet, right? No. And then we'll continue this conversation tomorrow. Your homework over 313 is due on Thursday. You might consider doing it